We will be taking up the topic which I've already noted down on the screen is application of trigonometry. See, this doesn't have any course in itself, right? You just have to read the word problem, draw the figure to yourself, and solve it. Now, basically, the one thing which you need to know under this is what is the angle of elevation and the angle of depression. Suppose I am drawing this line. The basic thing is when there is suppose an object which is here, and there is a person who is looking at from this point. He is looking up to that object from this point which is A. So BA and BC suppose is making an angle that is called the angle of elevation. Now if I change the figure and I make a case wherein the object is here and the eye or the person who is looking at that object that is here. That means the person is looking down to that object in the second case, and there is this angle which is formed, which is called the angle of depression. That means the both are making angles with the horizon. The eye which is making an angle with the horizon, here also so, but in the case of elevation the eyes are looking up towards the object, and here it is looking down towards the object. That is basically, the difference between the angle of elevation and the angle of depression. They both are the angle between the line of sight and the horizontal. This is called the line of sight. This is called the line of sight, and with the horizontal. They both are in that case written. Now taking up first, I'll be taking a very simple, and then in the next session maybe we can take up few hot question or the past paper questions. And just to get acquainted with what, how do you apply, let me just write a question. It says the angle of elevation. I'm using some short form so that I can write down the question quickly. Of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degrees. We have to find the height of the tower. I have again used this short form of height. Now to do so, let us draw a figure to yourself so that you can apply trigonometric ratios based on that figure. There is always a 90-degree angle we are talking about, and let us know what is our angle of what should be our tower. And so let me just name this triangle as ABC. The angle of elevation of a top of the tower, I have assumed the tower to be it should be an erect one, so it is AB to be the tower, and this C is the point which is on the ground, which it says is 30 meters away from the foot of the tower. So the foot of the tower is B, which is 30 meters away. This is 30 meters away, and the angle of elevation which it is making is 30 degrees. This means this is 30 degrees. Okay. Now there is this which is 90. Now if you look at it, the trigonometric ratios applied, we have to find AB, which I name it as x suppose. So what relation would give us this value of x? Which relation can be established? If I see this is 30, that means this is a perpendicular and that is base, so it is tan can give us tan 30 or tan C is equal to AB by BC. So tan C tan 30 is equal to AB, we have named as x, and BC is given to be 30. So x is 30 into tan 30. Tan 30 is 1 by root 3. So 30 into 1 by root 3, that is 30 by root 3, and if I rationalize it, I'll get it as 30 root 3 by 3. That's giving me a 10 root 3 meter. I'm really sorry for kind of overlapping that writing, but ultimately I'll get 10 root 3 meter will be the height of that tower, which is AB. Okay, let us now take up another question, not yet that difficult. Okay, I'll write down the question down. Wait, yeah. More the practice you do and where different types of question you attempt, you will be more comfortable with it, because it doesn't have any rule. You just have to draw the figure to yourself and then apply the trigonometric ratios. An observer who is 1.5 meter tall is 28.5 meters away from a tower. The angle of elevation of the top of the tower from her eyes is 45 degrees. Again, what is the height of the tower? We draw the figure to ourselves again. It says an observer who is 1.5 meter tall. So let us make an observer who is 1.5 meter tall. This is suppose an observer. This is 1.5 meter tall. Meter tall is 28.5 meter away from the tower. Suppose here you have a tower. So this distance is given by 28.5 meter, and let me name the tower as A and B. There is also a point of intersection here, so it is okay. I'll name them. This is C, this is D, this is E. There is no more intersection if I'll just join that. Now it says the angle of elevation of the top of the tower from her eyes. The eyes are, that means here. Okay, I need to join them. This is, if this is the height of a man and he is standing her eyes, sorry, a girl, I think it is her eyes. So here her eyes are here, and this angle which is formed is 45 degrees. All right, we have to find the height of the tower. Now which is our complete height of the tower? The height of the tower is complete AB, because I have assumed the tower to be AB. We will be finding AB then. Okay. Now if BC is 28.5, of course DE will also be 28.5. Now how can we get this complete AB? First let us decide what do we do to get it. To do so, first if I can find this height which is AE using the triangle ADE. And then we know ABE is 1.5 meter, and you add 1.5 meter to AE, that will give you AB. So we will see in the triangle AED, in the triangle AED, D. What is the relation? How do we find AE? AE again can be found out by tan 45. So I'll write tan 45. It's better I use my freehand to write. Tan 45 should be equal to AE by 28.5, that is perpendicular by base. So AE is 28.5 multiplied by tan 45. Tan 45 is 1, so AE is also 28.5. Now if I get this as 28.5 and I need to find AB as a whole, so it will be AE plus EB, which is given as 28.5 plus 1.5. That would give us 30 meter. So the height of the whole tower, which was AB, is 30 meter. I now move on to another question with a different application. Again, I need to write the question. From a point on the ground 40 meter away from the foot of a tower, the angle of elevation of the top of the tower is 30 degree. Angle of elevation of the top of a water tank. It also informs this is on the top of the tower, is 45 degrees. What do we have to find? Find is height of the tower and the depth of the tank. Let us again try to draw the figure correctly. This is a tower. I'll just not draw the tower, a big one, because we'll also have a tank on top of it. This is suppose our tower, which is of height h meter. Then from the foot of the tower, from a point which is 40 meter from the from the foot of the tower, I'll draw. This is 40 meter. The angle of elevation of the top of the tower is 30. That means this is 30. This is suppose our A, this is B, this is C. AB is our tower. AB is the tower that is supposed to be calculated. Now what it says, this is 30 degrees, the angle of elevation. An angle of elevation of the top of a water tank. Oh, there is a water tank. Yeah, this it also has informed it is on the top of it. So let me just draw a water tank. I'm assuming this blue is my water tank. Maybe this height. Oh, there is an angle of elevation which is formed again from the top of it, but from the same point on the ground. That means this whole is given to be 45. I'll just write it here. It's 45. And if I name ABC, this will be my D. And AD is the water tank. And that AD is the depth of the water tank. So we have to find both of AD and AB. Let us not give it its height. Let me write it as AD and AB. Now look at the triangle ABC. In triangle ABC, tan 30 is equal to AB by BC. And on the other hand, if we look at the triangle BCD, tan 45 is equal to BD by BC. So tan 30 is 1 by root 3, that gives AB, and BC is 40, that gives AB is equal to 40 root 3 by 3. Also this is 1, and BD is BD by BC. BC is 40, so it is BD is equal to 40. So to find them separately, AD is actually BD minus AB. So it is 40 minus 40 root 3 by 3. You can replace this root 3 with value and find it in decimal and subtract it. Okay, thank you.